this video, we will go over two examples in using the law of sines in solving a triangle. To solve a triangle means to calculate all the missing parts of the triangle. Now, what does the law of sines state? The law of sines states that the sines of the angles of any triangle are proportional to the lengths of their opposite sides. Meaning, when we divide sine A by its opposite side A, its quotient will be the same as dividing the sine of angle B by its corresponding opposite side B. And also, when we divide sine of angle C by its opposite side C. So let's go ahead and apply this principle of trigonometry in this example. Let's identify the parts of the triangle that are given. We know an angle, a side, and another angle. Since we know two angles, we can find the third angle of the triangle by subtracting the sum of 118 degrees and 22 degrees from 180 degrees. That will result to 40 degrees. So the measure of angle C is 40 degrees. Now let's pair them up. 118 matches with side BC represented by lowercase a. Angle 22 degrees matches with side B, which is unknown. And angle 40 degrees matches with side AB, which is 24 units. Now let's set up our equation. Let's first find the length of BC, represented by lowercase a. So, sine of 118 degrees over A is equal to sine of 40 degrees over 24. Let's evaluate sine 118 and round to the nearest thousand. So we have sine of 118 is 883 thousandths over A, and sine of 40 is 643 thousandths and divided by 24. Now let's cross multiply. So we have 643 thousandths A is the same as the product of 24 and 883 thousandths. The product of 24 and 883 thousandths is 21 and 192 thousandths. Then dividing both sides by 643 thousandths, and the length of A is 32 and 958 thousandths. Now let's round the side lengths to the nearest tenth. So in this case, it's going to be 33 and 0/10. This time, let's find the length of AC, represented by lowercase b. So we write sine of 22 degrees over B is the same as sine of 40 degrees over 24. Now you could also set up the right side of the equation with sine of 118 degrees over 33, since you already know the value of lowercase a, which is 33. Let's evaluate the trig values. So sine of 22 is 375 thousandths over B. Now sine of 40 degrees is 643 thousandths, and let's divide it by 24. Applying cross multiplication, we have 643 thousandths B is equal to the product of 24 and 375 thousandths. Let's go ahead and multiply those. That's going to be 9, and then dividing both sides by 643 thousandths. The length of B is 13 and 997 thousandths, which is rounded to the nearest tenth will be 14 and 0/10. Let's take a look at our second example. Let's identify the parts that are given. In the given triangle ABC, we know an angle, a side, and another side. Now let's pair them up. Angle A, which is 88 degrees, matches with 26, which is the length of BC. Angle C, which we don't know, matches with AB, which is 21 units. And angle B, which is also unknown, matches with side AC, represented by lowercase b, which is also unknown. Now, let's set up our equation. We write sine of 88 degrees over 26. So we have a pair given both the angle and the side. Let's find the measure of angle C since we know the side opposite angle C, which is 21 units. So we write sine of angle C over 21. Set up your proportion in such a way you have three values that are known, finding one missing part. In this case, it's angle C. Let's evaluate sine of 88. Round to the nearest. Let's evaluate sine 88 degrees. That's going to be 999 thousandths divided by 26 is equal to sine of angle C over 21. Let's cross multiply. We have 26 times sine of angle C is the same as the product of 21 and 999 thousandths. The product of 21 and 999 thousandths is 20 and 979 thousandths, keeping the left side of the equation as 26 sine C. Then dividing both sides by 26 sine C is equal to, round to the nearest thousandths, it's going to be 807 thousandths. Since we're looking for the measure of angle C, we have to use inverse sine. Now, the measure of angle C is equal to the inverse sine of 807 thousandths, which is rounded to the nearest whole degree, is going to be 54 degrees. Let's label our triangle since we found the measure of angle C, which is 54 degrees. Now we can use the two angles, 88 degrees and 54 degrees, to find the measure of angle B and eventually set up another equation to find the length of AC represented by lowercase b. So, to find the measure of angle B, we write 180 degrees minus the sum of 54 and 88, which is 38 degrees. And finally, let's set up our proportion to find the length of AC represented by lowercase b. We write sine of 88 degrees over 26 is the same as sine of 38 degrees over b. You could also use sine of 54 degrees over 21 since we already found the value of angle C. Let's evaluate sine of 88, which is 999 thousandths over 26 is the same as sine of 38 is 616 thousandths over b. Applying cross multiplication, we have 999 times b is the same as the product of 26 and 616 thousandths, which is 16 and 16 thousandths is the same as 999 times b. So b is equal to 16 and 0/10. There you have it, solving a triangle using the law of sines. Thank you for watching.